yesterday we looked at solving equations. We're going to continue to look at solving equations. These will get just a little bit more complicated as we move on. It's going to be one step, essentially, that gets added onto these. So we're going to do a handful of these together, and then I'm going to have you guys work on these on your own. We're going to do that, and then we're going to finish. I'll pass back your concept quizzes from last time. And so here we go. If you guys would, take a look at number 1 with me. Please notice how number 1 is a little bit different than the ones we did yesterday. Notice how on the left side there are 2 different x's. Do you see them both? 7x and negative 3x. So if you wanted to talk about how yesterday was different from today, I'm going to say there's essentially one thing that's different, and it is this. We are going to need to simplify before we do any solving. So simplify before solve. Simplify before solve. So simplify could mean a lot of different things. So we're going to kind of explore what some of those things might look like. So for this first equation, did you notice the 7x and the minus 3x are on the same side of the equal sign? So to simplify these, all we need to really do is add the like terms. So I would say that, bless you, 7x plus negative 3x is 4x. Yeah. So I have 4x plus 9 is equal to 12. That would be my first step. My first step is to simplify, and we want to make sure we do that with all of these. Simplify it down. Now, this should look a lot like yesterday. Would you guys please take just a second and try to finish this off, solving for x, and then work on checking. So I wanted to show you that first step, but I think you can probably take it home from here. So here we go. If I'm going to solve this, I need to get the x all by itself. Should I get rid of the 4 before the 9, or should I get rid of the 9 before I get rid of the 4?
The 9 before the 4.
Got to get rid of the 9. I think that makes the most sense. So how do you get rid of plus 9? That's right. So I subtract the 9 from both sides. Well said. This gives me 4x. The 9's added out to be 0 equals 3. And then how do I get rid of that 4? Because it's attached by multiplication. You're right. So I divide both sides by 4. And I get x is equal to 3/4. So I can check this. How would I check this? Plug 3/4 back in? Yeah. So maybe I'll just take this over here. I would get 4 times 3/4 plus 9 equals 12. Do you guys see how the 4s would cross cancel there in the check?
Yeah.
So cross cancel there. 1 times 3 is 3. 3 plus 9 is 12. And it checks. Therefore, I'm very confident that that's my solution. Any questions there? We good? Okay. So number 2. Remember, the first step we're adding to our equation solving is simplifying. Do you see any simplifying that could be done in number 2?
Yes.
What do you see? What jumps out to you?
Negative 2.
And the negative 2 should be doing what?
What's it called?
Distributive, yes. So we're going to distribute that negative 2. Doesn't this feel an awful lot like the quiz you just took?
Yeah.
That's why we say these skills build upon each other. If you can't simplify, it's going to be a real struggle to be able to solve an equation. So this would be 5 minus 2u plus 6 plus 9u equals 7. Are we done simplifying? Should we just start doing the whole solving routine? No, Chase says no. Irene says no. What do we need to do?
Add the u's.
Yeah, add the like terms. I've got negative 2u plus 9u. What does that add up to be? 7u. And then I've got a positive 5 and a positive 6. That is 11. So plus 11 equals 7. All right, so Nick, at this point, what do I need to do? I got to get rid of the 7 and the 11 because I want the u by itself. What do you think we should do first?
Subtract 11.
Agreed. So I subtract 11 from both sides. This gives me 7u equals negative 4. And then Jaden, what would I do to finish this one off?
Divide by 7.
That's right. So I divide by 7 on both sides. U is equal to negative 4/7. I did not direct you to check this one. I'll leave that up to you. But you do the same thing. You just plug it back in, evaluate, and see what happens. So far, so good? Any questions?
No.
Okay, remember, you're going to be doing these on your own, or maybe with a friend here in just a second. So make sure that if you need to ask a question, you're asking one. Okay? All right, so let's take a look at numbers 3 and 4. We'll get to 5 in a little bit. Okay, So number 3 is unique. What do you think is unique about number 3 as compared to the other ones we've done so far? What do you see, Joe?
It's got a variable on both sides.
Okay, hey guys, listen up. Josh, you too. Joe, listen up. Or Joe's going to say it again. Listen up to what Joe says.
It's got a variable on both sides.
You see it? We have not done that yet. That's what makes this one unique. So we do need to simplify this, and we need to get the y's together, essentially. Any suggestions on how I could get those y's like together, essentially? Chase, what do you think?
Flip the small number, so you would flip the negative 3y. So
What do you mean by flip?
basically, if you have a negative 3y, which you do, you would flip it over and it becomes a positive 3y.
Yep.
Add that to 5y.
Yeah, that's what I'm going to do. I think specifically what you chose to do is smart, because there's going to be fewer minus signs. So what I'm going to do is I'm going to go plus 3y and plus 3y to both sides. So let's think about what that's going to do. Over here on the right side, what is negative 3y plus positive 3y? 0, right? So it's basically been eliminated from the right side. And then on the right side, 3y plus 5y, 8y. So anytime you've got a variable on both sides, to simplify it, you want to either add it over to the other side or subtract it over to the other side, whatever is appropriate based on the sign of that term. Okay, so from here, basically it's the same thing we've been doing. Anna, what do you suggest we do first?
Distribute.
Distribute what?
The 4.
Oh, we're on number 3 still. Sorry.
Oh, okay.
I like your idea for number 4, but let's do number 3 first.
Okay, minus 11.
Minus 11 makes sense. We're going to subtract that 11 from both sides. This gives us 8y equals 16. Coy, how would you finish this one?
You would divide them by 8.
Yep, divide both sides by 8. There we go, giving us a final answer of y equals? All right, so that's our proposed solution. Again, I'm going to back off on the checking every single one of these. I think hopefully you got the point. You could take that 2, you could plug it back in, see if it really works, creates a truth. I think it would. You guys still doing okay? Any questions? Remember, you're going to be doing these on your own here in just a few minutes. So now would be a great time to ask a question, anything if you've got one. Okay, fair enough. Take a look at number 4. So, number 4, 5 also, both pretty darn complicated. There's a lot going on there. Remember, the first step that we're going to add on to these from what we did yesterday is to simplify. You see any simplifying that needs to be done? I mean, Anna mentioned something about a 4. What needs to happen with the 4? It needs to be distributed. Do you guys see any other steps kind of like that?
Yeah, 12.
The 12, yeah. Okay, so the 12 gets distributed there and there. Pay really close attention here. This is, I think, kind of a unique question. So if I distribute the 4, I get 4x minus 12 plus 3x equals, and then on the right side, I distribute the 12, and I get 12x minus 12 minus 5x. Oop. There we go. So you guys agree with that? Is that okay? That first step we basically just distributed twice. Do you see how there is a lot of simplifying yet to be done? Quite a bit. So we'll continue on with simplifying. On the left side, Victoria, what do you see?
4x and 3x.
They're like terms, aren't they? So when you add those up, what do you get? 7x and then minus 12 equals, and then wait, on the right side we have kind of a similar situation, right? 12x and minus 5x. It's pretty interesting. We haven't seen anything like this yet, but it might feel kind of confusing, and you might be kind of like, oh my goodness, what's happening here? I don't get this totally. But keep in mind, haven't we dealt with one of these situations where there's a variable on both sides? And so let's deal with that in the same way. We need to get those two variables together, don't we? So what would you guys propose? What could I do to get them together? Noel?
Subtract the 7x.
Yeah, subtract 7x, and I realize that that's the same thing on both sides. I get it. This is where it gets really interesting. What is 7x's minus 7x's? 0 of them, right? Just 0. So those will add out. So the left side just ends up being 0 minus 12, which is just negative 12. The right side, 0 minus 12, which is negative 12. So we end up with this negative 12 equals negative 12. What's missing on this step? There's no more variable. The x has added out completely. So this is a unique situation. This is what we call, you've seen this before, this is an identity. Okay? And the solution to this, because remember we're looking for numbers that make this true, make this equation true. Here is the solution. Does anybody know? No? Do you know? Hang on just a second. Can I get your question in 1 second? I want to finish this.
Any real number?
All real numbers. Yep. All real numbers work. So in other words, there is no number that you could plug in for x that would make this false. Any real number you plug in, it's going to be true. Okay? Jaden, your question.
Why didn't you just add 12 instead of like subtracting the 7x?
So good question. I could have done that. What I tend to do with these is I want to get my variables together first, because when I get my variables together, things start to clear up a little bit. As soon as I as soon as I subtracted the 7x from both sides, all of a sudden the variables were gone, right? They just added right out of there. And I get this negative 12 equals negative 12. I could have done that. So what I could do, I could still do it if I wanted to. I could, at this point, go plus 12 to both sides. If I did plus 12 to both sides, what would I get?
0.
No, I wouldn't get 0. I'd get 0 equals 0, right? The equal sign could never disappear. But I get the same result, right? So, Jaden, whether we did it your way, like in the ordering you did it, or the ordering the other way that we did do it, you're going to get to the same result. You're going to get to like negative 12 equals negative 12, or 0 equals 0, which is just simply a truth, which means that all real numbers are solutions. That will all work, and that would be the answer, essentially. Does that make sense? I would suggest that you avoid, I would suggest that you deal with the variable head on. I would say don't, leave that for the last thing to deal with. Does that make sense? Okay. Any other questions? That was pretty unique, wasn't it? That was maybe a little bit unexpected, because that was different than all the other ones we've done so far. So there's not one answer. There's infinitely many, right? All the real numbers will work. Okay, cool. Good. All right, let's take a look then at number 5. This will be the last example I do with you, and we'll leave the rest of these up to you. So, any suggestions on simplifying here? What do you see we could do here first, Ben?
Distribute the 2 and the 5.
So I don't think the 2 should be distributed, to be honest,
Why?
because there's no,
There's no operation.
Yeah.
there is its times. What should it be if it was going to be distributed property? Like what symbol would need to be inserted right in between the 3 and the x? Yeah, subtraction or addition. So if it was 3 plus x, I would agree on the distribution. But it's 3 times x, it's not distributed property at all. We'll get to that one in a second.
So you just leave it?
So we'll get there in a second. I will agree with you. We need to distribute the negative 5 though, right? So I'll just put this as minus 15x minus 5 and the 58. Let's deal with the 2 parentheses 3x. Now, I don't know how much you remember from the properties that you made the posters of. And by the way, I've graded the other classes. I haven't graded yours yet. I'm going to work on that this afternoon or tomorrow morning. So just be patient with me and I'll get those grades in for you. Anybody recognize the property for the first term? There is a property there. It's associative. There you go. It's associative property of multiplication. Isn't 2 parentheses 3x the same thing as 2 times 3 in parentheses times x? You can associate with multiplication. You can group the first 2, you can group the second 2, you can group all 3. The order doesn't matter. You can group whichever ones you want. The bottom line is 2 parentheses 3x is the same thing as 2 times 3 times x. And what's 2 times 3 times x? 6x. It is the associative property. So, but it's not the distributive. That's quite important to realize. Okay, so are we done simplifying? Got to add the like terms. What's 16x, or sorry, positive 6x plus negative 15x?
Negative 9x.
Negative 9x is right. Minus 5 equals 58. Callie, what do you think for next step?
You add the 5 on both sides.
You do. Yep, agreed. This gives us negative 9x is equal to 63. Kyrie, what about the next step?
Divide by negative 9 on both sides.
Agreed. Therefore, x equals negative 7. Again, you could check that quite easily just by taking the negative 7, plugging it back in, evaluating it, following your PEMDAS, and then seeing if it really is true. I think you'd find that it is. Okay, so we kind of explored a couple of different things there. These, I would say that these would represent probably the most complicated equations you will see in this course as far as linear equations go, solving them and such. So consider that. I have another set for you guys to practice with, 1 through 5 on the next page. If you guys would flip over, I will do the same thing. And I think while we're doing that, I will pass back your concept quiz 4. But I'll let you get started on this here. Here's numbers 1 and 2 at least. There's 3 more, and we'll just have to get there when we get there. For those that have the notes packet, it's going to be pretty easy. So if you guys would, work together, compare answers. We'll check them in a few. Check with me here, please. Number 1, did you guys see the distributive property? Okay, so distributing the 4, you would get 4x plus 8 minus 7x equals 0. Please carefully look at what you have on your paper. Look at what I've got up there and compare. Do we agree? Do we disagree? Are all the details the same? Make sure you're checking with me right here. Then on the left side, you guys see how the 4x and the negative 7x are like terms? So this would be negative 3x plus 8 equals 0. Notice how the 4x and the negative 7x were on the same side. So when they're on the same side, you just add them up like we've always done, right? Nothing too different about that. Finally, we've got to get the x all by itself. I'm going to subtract the 8 over from both sides first. Negative 3x is equal to negative 8. And finally, I'm going to divide by negative 3 on both sides, which gives me x is equal to 8/3. I think if you check that, I think we're in good shape. It'll check out just fine. Any questions? 8/3 go okay?
Oh my gosh.
Yeah, same thing.
Oh.
Any questions at all? No?
I get it.
Okay.
I've been rude with you guys.
Yeah, Noel, go ahead.
Oh, never mind. I just realized that. Okay.
You sure?
Yeah.
Okay.
I had my science songs I had when I was checking it, and that's why I didn't show up.
Fair enough. Ava, go
I have
ahead.
a question similar to the negative 8/3. Isn't it like a negative 8 and a negative 3, but that would just like be a
A
positive?
negative divided by a negative is a
Is
positive.
a positive. Okay, so it would be just positive.
Exactly.
Okay, I just didn't know why.
Thanks for asking. Absolutely. Anybody else with a question? Okay. So then number 2. This is where we've got an inequality. We did one of these last time. So with an inequality, much of the same way, we are going to be adding and subtracting for both sides, dividing both sides. I think you might have found maybe something interesting that happened here. I'm just kind of curious. How many of you, for your first step, decided to add 3x to both sides?
Nope. Me.
Did you add 5x to both sides?
Yeah.
No,
Okay.
I added 4.
So I think you should deal with the variables first, Coy, but let's talk about the variables. Did you add 3x to both sides or 5x to both sides?
I added 3x to both sides.
Okay, so I'm going to do it that way because I want to make a point about something. So you could do it the other way. And if you did it the other way, it's going to work out just fine. And this might be something you saw in middle school. We'll see. Maybe you did, maybe you didn't. What is negative 5x plus 3x? So this gives you negative 2x minus 4 is greater than 10. And then wouldn't you guys add 4 to both sides?
Yeah.
I think it's very reasonable to do that. So you'd go plus 4. You get negative 2x is greater than 14. And this is going to be the step where maybe you remember this from middle school, maybe you saw it in middle school, maybe you didn't. I don't know. Don't we need to divide both sides by negative 2?
Yeah, but then
Okay.
if you divide it, just switches.
So here's the rule, and this is going to be one of those moments where if you are a little unfocused for a minute here, you're going to miss this, and it's going to be frustrating to you, and I don't want it to be frustrating to you. If you ever divide both sides by a negative number, the inequality has to switch around. So I did just divide by a negative number, so that means I've got an x on the left, and I've got a negative 7 over there, right?
Yeah.
But instead of being greater than, it has to be less than because I divided by a negative number. I switched sides of the number line essentially by dividing by that negative number. Okay. So then on the negative 7, should I be putting a filled in circle or an open circle? Open on negative 7. And then the arrow should go which direction? Should go left. X is less than negative 7. Did anybody try the interval notation?
Yeah.
Okay, so the interval notation should be parentheses, negative infinity, comma, negative 7, parentheses. would be your interval notation version of that answer. So what that means is it's going to go way off the left edge of the graph, and it'll come all the way back over to -7, but it doesn't include -7, right? That's what the open circle means. That's what the parentheses means versus the bracket. Like I said, I'm only showing that to you because it's on website. If you guys have not looked at numbers 3 and 4, please do so. Where'd he go?
Oh, there's a 3 and 4.
I think so.
Oh, Lord.
It's 3, 4, 5.
Here we go, 3, 4, 5 on the same page. Even better.
Tomorrow morning I have my meeting.
No, it's before that. I mean, it's at the end of.
So guys, at least work on numbers 3 and 4 right now. Go ahead and jump in, get busy, get after it. We'll check these here in a minute. Just a few minutes left, man. 7 or 8 minutes left. Working on 3 and 4.
Yeah, I know.
Let's get focused. I feel like I'm having to come over and redirect you every time I walk by. Whoa, what?
No.
No what?
No, you don't. No.
How could you not find anything?
I don't know what to say.
You're not doing anything. That's what you should say. You need to start, okay?
Mm-hmm.
Okay? I can't help you if you won't help yourself. Yes, ma'am.
2 questions.
2 questions? Yeah, go ahead.
So on the ones that are, themselves like they just are identity or something, what
Yeah.
do we put as the answer?
All real numbers.
All real numbers. So it's
Yep.
okay then. And I either did
The answer should be
wrong or
Well,
The second one should be no solution.
you can go through and back and look. I mean, like, did you distribute wrong? I don't think so. Did you distribute wrong? I don't think so. That looks pretty darn good. And then 3y minus 2y is 1y. 4y minus 3y is 1y. You subtracted 1y from both sides. I don't see any mistakes in there at all other than the fact that you haven't finished.
I haven't finished.
You haven't quite finished yet.
How have I not finished?
We'll get there in a second. All right, let's take a look at number 3. Everybody's time. I want to go ahead and start this one. So do you guys see the 2 distributive properties? Yes? Okay. So 4x minus 12 plus 3x, and the 12 gets distributed, equals 12x minus 12 minus 5x. Maybe you can see this coming.
Yeah.
Should look really familiar, right? Yeah. 7x minus 12 equals 7x minus 12. It's the same question, isn't it?
Yeah, well,
It's really, really similar, isn't it?
You get the same answer.
yeah, you still get the -12.
Yep. You get negative 12 equals negative 12.
Oh, yeah, just
And in contrast to number 4, it's true. And so since the variable is added out completely and you ended up with a truth, you end up with an identity, or you could say all real numbers. That will be kind of the standard approach for that one. Okay, wow. We finished exactly on time. Well, hope you guys have a wonderful day. What was that, Brian?
I said, wow.